Good morning, everyone, and welcome to this lecture. We are into lecture number 10, and we are dealing with collision or impact in this class. In the previous class, we had seen about the impulse and when is normal force or tension impulsive, and we had seen that it depends on case to case. Gravitational force and spring force, though, whatever the case may be, they are non impulsive in nature. Tension, friction, and normal reaction it depends on case to case. Now, we are going to move into the next heading, the most important heading of this chapter, and that is known as collision or impact. Now, what is a collision or an impact? What do you mean by collision or an impact? Yes. Anyone has any idea what is a collision? Now, whenever we
When two bodies come to at one point is known as collision, sir.
collision or impact. Well, if I
Strong attraction between two bodies.
okay, let me let me draw some cases and try to make you understand. These two bodies are moving towards each other. Then I have two magnets kept at a small distance from each other. I have two charges kept at a small distance from each other. I have the sun and the earth moving around it. I have a body of mass m and a small body of mass m kept on the top of it. This is a bat and a ball is hitting the bat. These are 6 cases that I have drawn. Out of these 6 cases, starting from case number 1, which of them do you think are collisions and which of them are not collisions? 6 cases I have drawn. Which one is a collision and which one is not? Yes. Which? Yes.
First one, second one.
The magnets are not moving. I mean, I've kept two magnets close to each other, North Pole and North Pole facing each other. They are magnets. Which of them do you think is a collision and which of them is not a collision?
First, third, sixth.
First, third, sixth. In the case of third, there are also two charges are kept at rest close to each other. Why is third? Which of them are collisions and which of them are not? Only one, no one understands the question? No one else understands the question? Which of them are collision and which of them are not? All of them are collisions. All of these cases are collisions. All of these cases, collision is happening. So what do you mean by a collision? Whenever two bodies interact with each other, they exert forces on each other, and because of those forces, momentum of the bodies, any one body, it may not be even two bodies, momentum of any one body changes. That event is known as a collision. But when we are dealing with collision or specifically impact, that's why I've used the word impact here. Whenever we are using the word impact in real life or collision in real life, we are referring to a very specific type of collision. And in that specific type of collision, large impulsive forces will act on the bodies for a very, very small duration of time. Now, if you look at cases number 2 or 3 or 4 or 5, there are forces acting on these bodies, but these forces are acting for a long interval of time. So even though they are collisions, these type of collisions do not come into our definition. Only collision number 1 and 6, where large impulsive forces act for a very, very short duration of time. Only these two qualify as collision or impact. So whenever we are going to deal or whenever we are going to use the term impact, we are going to use for number 1 and number 6 type of collision. So if I write the definition of collision or impact, collision is an event where two bodies interact with each other exert forces on each other and their momentum changes. And their momentum changes. That event we can call is a collision. But here when we are going to deal with the term collision or impact, we are going to deal with the term with the specific type of collision or impact where large impulsive forces are going to act on the body. In our definition, large impulsive forces are going to act on the body for a very short time, and that impulsive force is going to change their velocity or momentum. So we are going to deal with those type of collisions where large impulsive forces are going to act, specifically collision number 1 and 6 That is the type of collision that we are going to deal with. Remember, in a collision, physical contact is not necessary. There could be an impact without having any physical contact. But when physical contact happens, then large impulsive forces starts to act. I hope everyone has understood this. Yes or no? I'll give you 2 minutes. Note them down. So, we are trying to understand what is collision, and the more you understand it clearly, the better it is, because this all chapter is about understanding what we are doing. Now remember, in collision, the actual time of collision, the time of collision, the duration of collision is very, very small. So basically, if you go to case number 5, now case number 5, the bodies are colliding, but the time of collision is very large. Therefore, this type of collision, or whether this type of collision does not come into our picture, because here the time interval is very large. Do you understand what I'm saying? Here, whatever we are going to deal in this particular section, there will be a very small time interval for collision. A ball hitting a bat, it is in contact for a very small or short interval of time. That is what we are going to study now. And again, when collision is happening, when this short time impact is happening, the effect of non-impulsive forces such as gravity and spring will not be taken into account. Why it will not be taken into account? Because we have already seen what? We have already seen that the impulse given by gravity is very, very small. Do we understand this? Yes or no? Now, once we understand collision, we understand that during a collision, what is happening is there is a redistribution of the total momentum of the particles. Momentum of the entire system, in most cases, will remain constant, and what is going to change is the momentum of individual particles. What it means is the momentum is going to get redistributed. The momentum of this particle and momentum of this particle, they are going to get redistributed. So they have momentum P1 and P2. This P1 and P2, the total momentum is just going to get redistributed and nothing else. So collision is nothing but a redistribution of momentum of the two particles or three particles or whatever particles are there. Okay, please note it down. So
Completed, sir.
we have seen what is an impact or collision. The next heading that we are going to write is the line of impact. LOI. Line of impact or LOI. What is this line of impact or LOI? This line of impact or LOI is the line along which is the line along which impact happens. And impulsive forces act. It's it's a line along which the body are having their impact, and impulsive forces act along this line. This is normally the common normal of the two bodies. This is normally the common normal between the two bodies. For example, if there are two bodies, one like this, M1, and one like this, M2, and they are moving towards each other, they are going to impact the common normal. This is the common normal. This common normal is going to be the line of impact. If two billiard ball 1 and ball 2 again are colliding, the common normal Cn, common normal Cn is the line of impact. Common normal is the line of impact in most of the cases. You have a wedge of mass m and a body of mass m is falling on this wedge. Remember, the common normal will be like this. This common normal will be the line of impact. Do we understand this? The line which is passing through the common normal is known as the line of impact. Impulsive forces act on this line. Momentum of bodies change. Momentum of bodies change along this line, because it is only along this line that the impulsive forces are going to act, and therefore momentum of the bodies are going to change along the common normal. Momentum of bodies do not change. Perpendicular to the line of impact, or you can call it CT, common tangent. Along common tangent, if I draw the common tangent, momentum along this line, common tangent, will remain constant. Momentum will only change along the line of impact, along the common tangent. Momentum is constant of the bodies. Momentum of the bodies do not change along the common tangent. Do we understand this? Now, in some cases, the line of impact may not be common normal. In some cases, the line of impact may not be along common normal. In that case, we can understand the line of impact. From the change in momentum. From change in momentum, we can determine the line of impact. How are we going to do this? I will show you a diagram. I will show you a case where we can determine the line of impact from the direction of change in momentum. So, in most cases, we can determine from the geometry of the colliding bodies. In most of the cases, 99% of the cases, it is going to be common normal. Very rare cases, and only one case can come in that category. We can determine it from the direction of change in momentum. If we know in which direction the momentum of body has changed, we can find out the direction of line of impact. Have you noted this, everyone? Okay, I'll give you 2 minutes to note it down. Let me know once you're done. Then let's move ahead. As I told you, in some cases we can determine the line of impact from the direction of change in momentum. In one specific case, if one of the particles is stationary and it has an impact, we can find out the line of impact from where that particle is moving. Take the case of a billiard ball. One billiard ball is hitting ball A, is moving and hitting ball B. Ball B is stationary. Ball A is hitting, but the ball B is stationary. After hitting, ball B starts to move in this direction. Initially, it was at rest. Now, you see that this ball is moving in some direction. You would have seen this in billiard or pool ball, the cue ball hitting one of the balls and the other ball which is at rest moving in some other direction. Initially, this ball B was at rest, but after collision it starts to move in the direction of the red arrow. From this information we can find out what is the line of impact. Where is the line of impact? Can you tell me the direction of line of impact from this diagram? Ball A was moving, ball B was at rest, which is the direction. What is the direction of the line of impact? Yes. What will be the direction of line of impact? Yes. Yes, I'm waiting.
Perpendicular.
I'm waiting for your answer. Yes.
Perpendicular.
Yes.
Perpendicular.
Perpendicular. What perpendicular? You tell me the direction now. You don't say perpendicular. Perpendicular to what?
Sir, along the motion of B, sir.
Where is the motion of B? Everything is on the board. Open your eyes and see it. What will be the direction of line of impact? It will be along this line. I don't know what you understand or what you know. This is the direction in which the body is moving. This is the direction of line of impact. Please note it down. Once you are done, please let me know. So this is the line of impact. Classification of collisions. The different types of collision, how can you classify them? The first type of collision, the first classification of collision is known as central and eccentric. There are two types here, central and eccentric collision. What do you mean by this central and eccentric collision? Central collision. What is a central collision? If the center of mass if the center of mass of the bodies
Sir, your
lie,
screen is not visible, sir.
you can write it, I am speaking. If the center of mass of the bodies lie along the line of impact, then the collision is known as central collision. If the center of mass of both the bodies lie along the line of impact, then this type of impact is known as central impact. Two bodies colliding like this, bodies moving like this and colliding. This is the common normal, or this is the line of impact. And you can see the center of mass of two bodies. The center of mass of the two bodies lie along the line of impact. This is the common tangent. The center of mass of the two bodies lie along the line of impact. This type of collision is known as central collision. The second type of collision is known as eccentric collision. Eccentric collision. In eccentric collision, if the center of mass of any of the bodies does not lie along the line of impact, then the collision becomes eccentric. Then the collision becomes eccentric. If any one of the bodies, the center of mass, does not lie along the line of impact, then the collision becomes eccentric. We call it eccentric collision. Central collision and eccentric collision. This is the diagram where you can see eccentric collision. This is the common tangent. This is the common normal or the line of impact. You can see the center of mass of this body lies here. The center of mass of this body lies here. Body B, the center of mass does not lie on the line, on the common normal or line of impact. Therefore, this is an eccentric collision. In this eccentric collision, there will be no rotation of the body. Now, rotation is a chapter which is going to come in the next class. Next topic is collision. In central collision, there is no rotation of the two bodies. The bodies do not rotate. Eccentric collision results in rotation of the bodies. Rotation of the bodies. And therefore, we are not going to study it now. We will be studying it when we do collision. So right now, we are going to concentrate ourselves into that collision where there is no rotation of the two bodies. Therefore, we are going to restrict ourselves to central collision. I'll give you 2 minutes to note it down. So let us move ahead. This is central or eccentric collision. We are going to study only central collision. The next type of classification, the second type of classification is based on the basis of line of impact. This was also basis of line of impact. Here we are going to consider velocities before and after the line of impact. So there are two types of collision in this category. The first type of collision is known as head-on. Head-on or direct or 1D collision. Head-on or direct or 1D collision. What is this head-on or direct or 1D collision? If the velocities of both the bodies, remember, both, if the velocities of both the bodies are where? Where should the velocities be? How should the velocities be? Along where? Along the line of impact. Then the collision is known as head-on or direct or 1D collision. Oblique or 2D collision. If velocity of any of the body is not along the line of impact, then the collision is known as oblique collision. Or collision in 2 dimensions. You can see here Case number 1. This is the line of impact, common normal or the line of impact. This is the common tangent. The velocities of both the bodies are along the line of impact. Therefore, this collision becomes head-on or direct collision. Head-on or direct collision. Second case, and you can see here, if any one of the bodies is not along the line of impact, any one, it becomes an oblique collision. Here you can see only one ball is moving, the wedge is stationary, but the line of motion of the ball, the line of motion of the ball is like this, and my line of impact or common normal is like this. Therefore, this is an oblique collision. I hope we are able to understand this. One more. And in this case, you will see both the bodies are having different velocities in different directions, which is not along the line of impact. This is the line of impact or the common normal. Both the bodies are moving in different directions. Therefore, this collision also becomes oblique. Head-on collision, both the bodies should have their velocities along the line of impact. So, velocity should be along the line of impact. Head-on collision. The center of mass should be along the line of impact. Then it becomes a central collision. Case number 1 that we see here, case number A, is a head-on central collision. Case number B is an oblique central collision. Case number C is also an oblique central collision. Do we understand this? Yes or no? Okay, note it down. Well, I hope you have drawn these diagrams and understood the types of collision that we have done in today's class. In the next class, we'll move ahead and see the other type of collision and try to wind it up in 1 or 2 more classes. We will be paying more attention onto the head-on collision or the direct collision because those are the questions which are more likely to come. We'll also do some questions on oblique collision. Eccentric collision will be coming in the chapter of rotation. I hope everyone has understood today's class. Yes or no? Again, request, warning, whatever you call it. When you come to the next class, please go through what we have done in today's class. Otherwise, you will not be able to understand anything in the next class. So please revise and come in the next class. Take care. God bless all of you. Bye-bye.
Thank you.